Hey, so a couple questions on IUPAC nomenclature. So I thought I would just kind of jump on and do a quick recording of some of those examples from the homework, because really, I know many of you have asked, what is the best way to do this? What is the easiest way? How much of this do I need to know? And unfortunately, I don't have an easy answer for you. Organic chemistry is really like learning a new language. So the best way is just practicing those rules, practicing walking through those steps of the IUPAC nomenclature. Go from name to structure, structure to name, back and forth, find some structures on the internet, name them and check, or draw some structures and check. Or go from make up some names and try to draw the structure. That's honestly, that's how I learned this material. That's the best that I can say. And you can have those rules handy with you, those IUPAC rules when you're going. You can have those tables handy with you when you're working on this, because it just helps to have it there as a reference. So taking a look at this first one here, right? Identify the longest continuous carbon chain, the longest continuous carbon chain. And we want to count that chain so that we have the branch with the lowest number possible. So 1, 2, 3, and 4, right? That puts the branch on the second carbon if we count from the right. So I have 4-carbon alkane, which is butane. And on the second carbon, I have a methyl group. So I would say I have 2-methyl, right? On the second carbon, I have a methyl group. And the chain is 4 carbons long. So that would be choice C, 2-methyl butane, right? If I counted from the left, I would get 3-methyl butane, but that's not the lowest number possible. Pentane would be if this was a straight chain, 5 carbons long. It's not a straight chain. I've got a branch, right? And 2-methyl pentane also doesn't work because we only have 4 carbons, right, in the longest chain. Isopentane would be an isomer of pentane. And again, we have a more appropriate IUPAC name for this, which would be 2-methyl butane. Some of the other ones were condensed structure, which might make it a little bit more challenging. So I'll just draw out the condensed structure, right? We've got a methyl group. I've got a methylene, right? Carbon double bonded to a carbon, a hydrogen there, a methyl group, and a methyl group. That would be the same structure. So to name this, we want to find the longest continuous carbon chain that contains the double bond now. And we could either use the methyl group to the top or the methyl group to the bottom. It doesn't matter. We're going to get the same name in this case. So there's my longest continuous carbon chain. It would have 1, 2, 3, 4, 5 carbons in it. And I would see the same thing there. 5 carbons, and I want to have the branch, right, have the lowest number possible. I want to have the alkene, most importantly, have the lowest number possible. So I would say that on the second carbon, I have a methyl group. So 2-methyl, 5 carbons long is pent, and I have a double bond at the second carbon. So it would be 2-methyl, pent, 2-ene. Right, that would be the newer way of saying it. The older way of saying it would be 2-methyl, 2-pentene. So I've got 5-carbon hydrocarbon that has a methyl group on the second carbon, and that double bond also starts at the second carbon. This would be the newer way of saying it because you're putting that 2 right next to the ENE, letting you know you have a double bond present. The older way would be the 2-methyl, 2-pentene, and that's what we see here in choice D, right? 2-methyl, 2-pentene. Right, methylpentene, that's not good enough because it doesn't let us know where's the methyl group, where's the double bond. 2-methylpentene doesn't let us know where the double bond is. 4-methylpentene, you counted from the left, and again, it doesn't let us know where the double bond is. And E4-methyl-3-pentene, again, you counted from the wrong side. We want to have the lowest number possible for our double bond. Right, here's another one. And so I'll draw the full structure just to help us see everything. And I've got a methyl group over here. My apologies. So longest continuous carbon chain would look like this. And we could include either one of those methyl groups. We're going to get the same name. So longest continuous carbon chain, we want to have the lowest number for our branches. We want to have the most branches have the lowest number possible. So we're going to count from the left, 1, 2, 3, 4, and 5. So that would be pentane, right? And then on the second carbon, I have 2 methyl groups, and on the fourth carbon, I have a methyl group. So putting that all together, we would have 2, 2, 4 trimethyl, just squeezed it right in, pentane, right? So that would be choice A, 2, 2, 4 trimethyl pentane. I have 2 methyl groups on the second carbon and a methyl group on the fourth carbon, right? I'm going to count from the left because I want to have both of those methyl groups, right, to have a lower number if possible. If I counted from the right, I would have 2, 4, 4, right? I can get a lower number by counting from the left. And so that's why this one is wrong here. And then for the butane, right, we can get a longer chain, and that's why choice B is wrong as well. Isooctane and isomer of octane, we're looking for the IUPAC nomenclature. This one is an ether, and so ethers are a little bit different, right? CH3, CH2O, CH2, CH2, CH3. For ethers, we name the shortest chain first, and then we name the longer chain as the base name. So the shortest chain for this ether is 2 carbons long, and the longer chain is 3 carbons long. So we would say I've got ethyl, the longer carbon, because that's 2 carbons, right? 3 carbons is propyl. So I would have ethyl propyl ether. I've got an ethyl group, oxygen connected to a propyl group, right? And then the oxygen between 2 carbons, single bond on both sides is an ether. And the last example, this one also, right, they gave you the condensed structure, so it's a little bit more challenging to see in the condensed structure. So let me just draw that out. I've got a methyl group, I've got this carbon, I've got a methyl group, and I've got this carbon, 2 hydrogens here, a methyl group here, carbon, and that methyl group. So let me just fill in the hydrogens. Right, I need 1 more hydrogen there, 1 more hydrogen there, and I think I've got the structure. So now taking a look at this one, again, longest continuous carbon chain. So my longest continuous carbon chain, right? I could go this way. I could also go this way. I'm going to get the same answer both ways. So I'm going to go with the red. And now I want to number this in a way that gets me the lowest number possible for my branches. So I want to number this from the left. So 1, 2, 3, 4, and 5. Seeing that down here, 1, 2, 3, 4, and 5. Off of this chain, I've got 2 groups. I've got a methyl group and an ethyl group, right? Here is my methyl group, and here would be my ethyl. So putting that all together, we want to put these groups in alphabetical order. So E for ethyl comes before M for methyl. So we would say, I've got 3 ethyl, 2 methyl. So I've got a ethyl group on the 3rd carbon, a methyl group on the 2nd carbon, and my main chain is 5 carbons long. So pentane. So taking a look, right, that looks like it's choice B, right? 3 ethyl, 2 methyl, pentane. We can cancel out choice A because that would be if you counted from the right, right? We want to have the lower number possible. So we don't want to count from the right. Choice C, we didn't number anything. And choice D, we added an extra carbon somewhere somehow. So we can cancel that out. And then 1, 2, 3, 4, 5. 2 ethyl, 3 methyl. I'm not sure how they counted that example to come up with those numbers for choice E, but that doesn't match our numbering that we see either. So choice B is the best for those. So hopefully these practice examples, these are right from the homework. So hopefully these help with your homework problems. If you need any more help, just let me know. I'd be more than happy to work through an IUPAC question with you.